Morning, everyone. Let's begin. We are a bit of luck today. We are going to finish cylindrical coordinates, triple integrals. This is a version of question 8. So we're not finding volumes anymore. We're actually finding the triple integral of a guy called x squared. And the region E is described as follows. So there's a lot going on in this particular fella. Essentially, you've got a cylinder and you've got a cone. So one is eating into the other. So you can imagine a cone might look like this. And then you've got a cylinder kind of, doing its thing. I tend to think of drilling holes through things as one way of looking at it. And sometimes the volume that you're trying to calculate, although it doesn't need to be a volume, the region in this case that you're trying to calculate might well be what's left, or it might be the solid part that actually is the hole, like a donut hole rather than the donut. Now, this here is E. So looking at this guy, and we're going to be using, of course, cylindrical, which I very often say is polar. So I'm going to take this piece of information and this piece of information. Now, since it's above Z, I know that. And if I rewrite this, isn't that 16R squared? Do you agree? And isn't that technically plus or minus 4R? But since I know this is 0, I can get that. Are you happy about where I got the limits of integration for the Z? I used the fact that Z was above 0 and I used this guy. Now, when they say within the cylinder, they're actually talking about this piece here. And so this basically is the ground, which is a nice little circle of radius 9. Radius 3, I should say. And so there you go. So we're going to be doing the integral from theta equals 0 to theta equals 2 pi. We're going to do from r equals 0 to r equals 3. And we're going to do from z equals 0 to z equals 4r. X squared is going to become r squared cos squared theta. Then we're going to have an r, a dz, a dr, and a d theta. I'm not going to write the next line, but wouldn't I join these together and get r cubed? And from that point onwards, isn't it just a triple integral? What's going to cause issues? I think you're going to end up having to integrate a version of cos squared, aren't you? There'll be some multiple in front of it, but eventually, aren't you going to have to multiply some multiple of cos squared? I'm just looking at that guy, right? The guy's going to transfer all the way down. So what's how are you going to get the integral of cos squared? And no, it's not a user.
Can we use a trig identity?
Correct. Can you remember what?
Isn't it 1/2 times 1 minus cosine of 2 theta?
Almost. Add it.
Oh,
You're done. Right, and yeah, you know how to do that. So that's as much as I want to do in the 8. Did something similar to 9 yesterday, so I won't worry about that. Did something similar to 10 yesterday, I won't worry about that. Let's do 11. We're back to finding volumes again. So that means we're doing a triple integral of 1. And the region E is a solid enclosed by a cone, which is that guy, and a sphere. Oh, yeah, interesting. Didn't we do a cone, a cylinder and a sphere last time? Right, so it's sort of a kind of, but not the same as. Right. What do we know? It's right. So we're going to have to figure out how to take the intersection of these two that's going to make a solid. So what the heck did that look like? So you've got a cone pointing up the way. And it's going to meet at the origin. And then you've got a sphere, which is going to interact with that cone, something like that. Can you imagine a cone that's got a curved top to it? I mean, my best guesstimate of what this shape looks like. Would be something like that. Doesn't help to answer the question, I'm just trying to visualize it. So somewhere in here, we have got to find our limits of Z, because that's where we go first, right? And since I took up so much room, I'll just do it over here. Z equals the square root of x squared plus y squared. And that becomes the square root of r squared, which becomes r. Are you comfortable with that? Now, x squared plus y squared plus z squared is 169. And I'm going to use that to generate a z as well. So that makes z squared 162, take away x squared, take away y squared. Well, that makes z squared 162, take away r squared. Are we comfortable? Remember, z cannot be having x's and y's in it, right? Z can be numbers or things with r. I don't think I've ever seen a question where it's got theta, but again, theoretically, it could have a theta in it. Which means that we now have to put this guy into that guy. Now, technically speaking, shouldn't that be a plus or a minus? Right? But why am I only picking the plus?
Because we're looking for the volume, so it would only be positive.
Well, we are looking for volume and it should be positive, and that is, those statements are true. My very, very badly drawn picture, isn't that the floor? So doesn't that make Z positive? And that makes this has to be positive. If you chose the negative one, wouldn't you get a negative volume? And that would be, I think I got the guy wrong, and you would fix it with a plus. This has to be used, right? So I only have one choice, plus or minus. Are we good? Right, so I've got my Z set up, not very pretty. Now I need to find what the intersection of those two regions looks like when you project them onto the floor. And I'm pretty sure I know what it looks like. Won't it be a circle? But I have to find out what the equation of that circle is. So I'm going to go back to Z equals the square root of x squared plus y squared, and the x squared plus y squared plus z squared equals 162. And I'm going to set them equal to each other. In other words, how do they intersect? Well, it would probably be helpful to call that z squared equals x squared plus y squared, and then replace it in here. And so what you got is x squared plus y squared plus another x squared plus y squared. Right? And that's 162. And I'm getting a little bit of deja vu here as far as the numbers go, because doesn't that get me an x squared plus y squared equals 91? So that circle that would be on the floor is basically a circle of radius, 81, is a circle of radius 9, and it's the entire circle, so 0 to 2 pi. Does that look good? Right. You put the whole package together, then it's going to be a triple integral of 1. The z is going to go from r to 16 take away r squared. The r is going to be 0 to 9. And the theta is going to be 0 to 2 pi. And there's one more decision that I have made arbitrarily. Haven't I put the r here and the square root up there? If I got that wrong, would the answer be correct numerically but negative? So if I do accidentally get it wrong, right, I put one above the other and it should be the other way, won't you just change your answer to positive and save yourself a lot of work? Now it's going to be a 1 r dz dr d theta. And I'll do one level of integration on this one. We are going to be doing so it's going to be from 0 to pi, from 0 to 9, r square root of 16 take away r squared z. Ooh, that's interesting. Evaluated at z equals r and z equals, don't know why I'm putting 9 there. 16 take away r squared. That is weird. That is really weird.
Mr. Robertson, shouldn't
Yeah.
so when you first wrote down the limits of z, wouldn't it be r to root 162 minus r squared?
Yeah, it should be. That's why I didn't come out. Pretend I didn't do that, guys. Kind of knew it wasn't working out right. Too busy thinking of a question that's coming after this. This becomes ZR, evaluated at Z equals R and evaluated at Z equals 16 take away R squared. You're going to get a Z square root of 16 take away R squared, and that Z is not correct. It's R times that guy. Take away R times R, which is R squared. Right. So technically it's a square root of that times that, but I just stuck it at the front. This guy is going to be your U sub. And this guy is just going to be that guy. And basically off you go. Yet another boring U sub. I'm getting tired of U subs. "12 is very like it, so I'm not going to talk about 12. "15's interesting, I believe. Let's kind of jump out of order, because that's the one that's got my... Was it 15, Matthew?
Yeah, but I honestly got lost. Like I have no idea what to do on 15, so
Okay, let's just do it because it's obviously a very difficult question. So we're being asked to find the mass of something. And we're being told that for the mass of all, given that this is true. Okay, so what do I know about the mass of a ball? Well, we're told that x squared plus y squared plus z squared is less than or equal to a squared. And we're told that the density function is just k. And it's k times the distance from, it's k times, I thought it was going to be something like that, the distance from the z-axis. Wow. Okay, so I know I'm going to do a triple integral over some region called E, and that's E. And I'm going to be doing a density function. Evidently, it's going to end up eventually being cylindrical, but I'll just call it dV by now. And let's just focus on this fella. What if you imagine a general point? That's this point here, with coordinates x, y, and z. The most common one I've seen, isn't it, that they make it the distance to the origin, right? In which case, it would be the square root of x squared plus y squared plus z squared, right? I've seen ones that do that. But this one doesn't want to know that. It wants to know this distance here. Now, that guy there has coordinates 0, 0, z, because isn't he the same height as that point there called x, y, z? So far, so good. Now, that distance, I'm going to call this q. To get the distance pq, I need to know the distance from a point called 0, 0, z, which is him, to the point called x, y, z. So it's totally general. Well, the distance formula is the square root of the difference in the x's squared plus the differences in the y squared plus the differences in the z squared. So are you comfortable with that distance being that guy? Does that make sense? So our density function is k times this guy. So the mass of this object is the triple integral over some region E described by this guy, k times x squared plus y squared. So that's kind of where we are right now. Not that far into the question, but every little bit helps. Now, if you are talking about a sphere, when you tell me x squared plus y squared plus z squared is less than or equal to a squared, you're just talking about the inside of the sphere. The surface of the sphere is x squared plus y squared plus z squared equals a squared. And I am going to find z. And I'm going to do it by subtracting x squared and y squared from both sides, and then going to call that a squared take away r squared. I'm then going to call that the square root of a squared minus r squared. And we finally get to do a plus minus, because on this shape, isn't the z going to be above, and it's also going to be below the xy plane? And the xy plane is this plane here. So I now have my z values. Not pretty, but I do have them. A squared, take away r squared, and negative a squared, take away r squared. Are you comfortable about the limits of z? So can you imagine a random point, you know, above and below, right? That would be the z value of it. Now, if you take the sphere, because there's only one object here, and you look at its shadow on the xy plane, can you visualize that you're looking at it above, straight down? Won't you just see a circle? Right, on the shadow on the xy plane, right? And what will that circle look like? Well, won't that circle be x squared plus y squared equals a squared? Right, can you imagine a sphere? Cut it down the middle where the xy plane is. Can you see the circle it would make? X squared plus y squared equals. That tells me that I have got a 0 to a. And thankfully, I got some numbers. That is what E looks like. From two ugly Z's, a reasonably nice, think A is a constant, by the way, right? So it's from 0 to 10, right? And then finally a 0 to 2 pi. So we have all the pieces. Now we'll move them over and see what we get. So the mass of this object is going to be from theta equals 0 to theta equals 2 pi, from r equals 0 to r equals a, from z equals ugly square root to equally ugly square root, k. What will the square root of x squared plus r squared now look like when we do the polar on it? And then don't we have another r, dz, dr, d theta? Remember the extra r because of the cylindrical. So it looks like we're going to go from 0 to 2 pi, from 0 to a, from ugly z to just as ugly z, of k times r squared dz dr d theta. You still with me? Right. Going to do one level of integration. Let's focus on just that guy. And I think I'm going to need quite a lot of room. So I'm just going to do over here. If you integrate, well, let's put this in first. That's the guy we're focusing on, right? If you integrate this guy, don't you basically just introduce a z? Are we good? So, I get that. What does that look like? That looks like
That's where I got stuck. Because you could do an integration by parts with a u sub inside of it, but then that wouldn't get you anywhere. And I also did like a u sub of a u sub from
Yeah,
there.
let
And
me
that didn't
check.
really work all that well either.
Yeah, I'm looking at this. Oh, they used the back of the book, the 200 special integrals. That's what they did. You cannot the next line, right? You're going to have to do r equals 0 to r equals a, right, of dr. That's where the problem is, right? If I had been r, wouldn't we just bug Mia and say u sub and she would tell us, right? That's an r squared. You will have to go looking, and the answer is that there is a standard integral for that guy. And I'm just telling you what the answer is because it's in front of me, because nobody memorizes all the standard integrals. There's over 200 of them and nobody's got that kind of memory. You get, oh damn it, they've actually combined it, so it's hard for me to tell what they, no. They skipped a line and jumped right into what the answer would be, but that is a standard integral. Let's go hunting for it. Let's pretend that you were doing this question and you were in the same boat, right? I don't know how to integrate that. It's not a one that U sub works for. And so I'm going to go into 264 and I'm in it and I'm going to find the ebook. Okay, let's go. Y'all looking at this guy? Right, so is it under formula cards? I think it might be. I've never looked at it. The one I've got that I hardly ever use anymore is physical. Okay, so I don't know what reference page 1 does. Okay, it does algebra stuff.
If I'm correct, I believe it's on reference page 7 and it's number 31.
There you go.
Okay.
There it is. You nailed it. The integral, think of that as being r, right? So the integral of r squared, the square root of a squared minus r squared, is that ridiculously ugly mess. You see it there? I know it's ugly, but you're not meant to memorize it. You're just meant to use it. I really wouldn't do that to you. But if I did do it to you, wouldn't I have hint the integral of r squared, the square root of a squared minus r squared equals, and I tell you what it was. In other words, you would get to the answer from there. Oh God, that is horrible. That is one ugly equation. I apologize. That would not be a really nice question to give any human being. Would you agree? It's just downright ugly. I don't always know when I pick a question what the technique's going to be. I'm assuming when I pick them that the question looks as this one did. Nice and symmetric, so therefore the math wouldn't be too horrible. But I got it wrong. But it is doable, even if it's ridiculously ugly. So where are we off to next then? Is that 14? Let's work backwards. That way I know I've covered the worst case scenario first. Okay. Think. That's question, that was question 15, wasn't it, that one? Right. Let's just kill 15, eh? Make life easy. Did you fight your way through it, or you just knew that one, Mia?
I just had my reference sheets out.
In front of you.
Looking for it.
Okay, so it's, I don't, you know, it'd be horrible if you spent 2 hours doing it and then I say, oh, we're going to kill it, because I can
No,
imagine.
I haven't even attempted it yet.
Right, okay, so 15 will not exist in whatever time it takes me to do it. So that kind of makes me feel a little bit better that you're not landed with it. Hopefully, Matthew, you didn't spend too much time before you just threw your arms in the air and says, I'm not doing that. Were you okay?
Yeah, only like 10 minutes or so, probably.
Okay. Well, you know, that's 10 minutes of your life you're never getting back again.
I mean, I play video games a lot, so I understand the feeling.
Okay. So question 14 is we're going to find a centroid. So let me check that that one comes out. That one comes out nice. Okay. So the surface that we're going to look at here is one that's between two different shapes. It's between that guy, which is a paraboloid, which I think looks something like that. And
Mr. Robertson.
you can't see anything. I gotcha. Yeah, I have enough time to do this one, and that'll probably be us for today. Okay, so we have this guy, and we have 2 times x squared plus y squared, which is a cone. So can you imagine one of these meeting up with one of them? So actually, I can imagine what that looks like. Can you imagine you've got a cone and then somebody bolted on a kind of acorn-like shape? It's an ice cream cone. That's what that would look like. We want to find the centroid of an ice cream cone. Right? And there is an awful lot of symmetry going on in this shape. So before I even start, I'm going to show you a trick. If the shape has symmetry to it, you can very often predict some of the values. Sometimes the value is the same as the other one. In other words, x bar is the same as y bar, right? But in this case, why can I say that? If you imagine this shape, and this is where the xy plane is, right? At the boundary between those two. Can you see that vertically above, when you look at that shape, isn't it a circle? It's balanced, it's symmetry. So the only guy we need to do is find out z bar. So that's going to cut down on our work a little bit, but there's still enough work to go around. First thing we're going to get is the mass of the object, right? Actually, I'll call it the volume. Later on, it'll be a mass. And that's going to be the triple integral of E of 1 dV. Now, we've done a couple of questions like this before. If I rearrange this guy, are you comfortable that it ends up being 48 take away r squared? And if I rearrange this one, are you comfortable it being 2 times r? Are you good with the z's? Right, so I'll do my z's first then. So z equals and z equals. Now, I know that the cone is the below shape, right? And this thing is the above shape. So that tells me that I'm going to make this one here the top one. And I'm going to make this one here the bottom one. And we're good. Now, if you imagine the intersection of those two shapes, don't they make a nice perfect circle? And how would I find the equation of that circle? Well, wouldn't I take this equation, and I'm going to rearrange this second one by squaring everybody. Are we good with that? So I want to find out what are these things. Better check that. Is it 48? Yeah, it is. Oh. I'm going to get x to the 4s in this. Oh, okay. Just to make my math a little bit easier, I'm going to actually use this version. Don't normally do that, but when they are equal, isn't that true? I know it's a circle, right? I can visualize it's a circle. So don't I just need to know the radius? Because won't theta, because it's a whole circle, be 0 to 2 pi? You agree? So I need to find out what the radius of the circle is. So I'm doing it that way because it's a little bit less work. Any suggestions for where I go next?
Would you just factor it?
Well, eventually, but when I have to figure out how to write it down in a way that's going to be factorable. Right now, I don't like the way it's written.
So 48 minus r squared minus 2r?
That would work. I'll just go the other way. What you said is right. I'm just going the other way. Can you think of the factoring that works here?
R plus 8r minus 6 should be
Yeah.
it.
Yeah, and this one gives me an answer that makes sense. And will we agree that -8 radiuses don't make sense? So we'll not use that one. Which tells me, yeah, that's how I found that was 6. I knew it was a circle. I could visualize that. What I didn't know is what its radius was. And so I matched these two together. I was originally going to do that. Then I thought, oh God, that's going to be really ugly. And this just was easier. And of course, it's going to be 1 dV. Can I do a ... in that and tell you that the answer ends up being 792 pi? Will you just accept that as kind of done, right, for speed? Now, for part B, we're eventually going to get the centroid, but first we're going to have to get the mass. And the mass is quite simple. The density function is K. So won't the mass simply just be K times the volume? So 792 K pi. So if you tell me that the mass is a fixed value K, the density function, I should say, is a fixed value K, then won't the mass just be the volume times the fixed density? And so you add an extra K to the answer. So we got that bit without too much trouble. Now we have to do a 3-dimensional center of mass. And what you do is you find, because I'm interested in the Z only, remember that was the only one that wasn't 0, we find this guy here. Now this guy here is going to be the triple integral over the region E of our guy, and our guy is Z times the density function, which happens to be K. If you want to know what the other two are, there's an XY, that's the moments about, that's the one I just did actually. So you've got XZ, which is the moment about Y. And the other one would be YZ, and we call that the moment about the X's, and that's would be it. But I know that these are going to be 0, so we skipped that. So the moment about XY is going to be the integral from theta equals 0 to 2 pi, from r equals 0 to 6, from z equals 2r to z equals 48, take away r squared. And it won't be 1. The only difference is it's going to be k times z. And it's going to be, what's that, r dz dr d theta. And if you do all of that, which will certainly take a heck of a long time, you will get what will you get? Let's just write down what they said you would get. Thank goodness. 16,848 pi k. Well, you just trust that when you do that integral, that's the answer that you get, right? This is not a hard one to do. Wouldn't it just be a really long one to do? Now, to get z bar, it's the moment over xy divided by the mass. So it's going to be 16,848 pi k divided by a mass which was 792 pi. And I think there was a k in that, so yeah. And kill, ugly fraction. Ugly fraction is 234 elevenths. And so the centre mass of that object was 234 elevenths. So the centre mass of that ice cream is going to be somewhere up here because it's positive. If that number had been negative, it just means the centre of mass would be somewhere below the XY plane, which could happen, I guess. Are we good on that? Now, if I gave you a question like that in a midterm, I would probably tell you the X bar and Y bar are both equal to 0 by symmetry, and just ask you to find the Z bar. So you know you don't need to do everybody, just to make your life a bit quicker. Okay, let's do some quick questions while I'm thinking of questions.